Hello everyone, welcome to the Electron Flow Academy. So today we are going to discuss about the numerical problem number 3. In this problem, the question is as follows. An iron choke coil takes 4 ampere when connected to a 20 volt DC supply, and the same iron coil takes the 5 ampere from the 65 volt 50 hertz AC supply. So there are three parameters which we need to determine. Firstly, resistance and inductance of the coil. Second, the power drawn by the coil and the power factor of the coil. So in this question, the word is used here, shock coil. Okay. So from this, we have identified that the load is of type series RL load. Okay. So this is how we have to identify the type of the load. Sometimes the type of the load is not given in the question. Okay. The word is used here is the coil. Okay. So here uh, let's start the solution. Okay. So as per the question, when the choke coil is connected across DC supply, the inductive reactance is 0. Okay. When choke coil is connected to DC supply, that means the inductive reactance means X of L, or we can say that the 1 minute omega L. Okay. So here this is the omega L. So the value of the omega L in the case of the DC is 0. So therefore, the ratio of applied voltage to the current is equal to the resistance of the coil only. Okay. So from here we can calculate the value of resistance. So we know that the R is equals to V upon I as per the Ohm's law. So here we have the 20 volt DC and the 4 ampere current. So we can calculate the value of resistance here, 20 divided by 4, which means the value of the resistance is the 5 ohm. Okay. The next thing is that is asked, when connected to AC supply, the impedance of the choke coil we can calculate here. So second here, when connected to AC supply, that means we can calculate here the impedance Z. So we know the formula of the impedance, which is equal to V upon I. Okay, so voltage is given is here 65 volt, which is AC. Okay, and the value of the current in the AC is 5 ampere. So 65 divided by 5, which gives us the value of the impedance is 13 ohm. So here we have calculated the value of Z, the value of the R. Okay, and we know that Z is equals to under root of R square plus XL square, or we can say that the Z of square equal to R square plus X of L square. So here we have to calculate the value of XL, okay, with the help of this formula. So XL is equals to under root of Z square minus R square. So after the putting the value of the Z and R, the value of the XL is equal to 12 ohm. Okay. So Z square means 13 square minus 5 square. So we will get the value around 12. Okay, so here combinedly we can rewrite the equation for the series RL load. So the impedance is equals to R plus J times XL. Okay, so value of the R is here 5 plus J of 12, or we can rewrite this in the terms of polar form. So which will equal to 13 at an angle of 67.38 degree. Okay, so this is the polar form and this one is the rectangular form. Okay, so till now we have calculated the value of the impedance. Okay, so next, so first point we have calculated here successfully. This is we have calculated. So next is that the in the question it's asked is that the power angle. Okay, so the power angle is equal to power angle. We know that the power angle or the power factor, we should use the word power factor here, is the angle of the impedance. So cos phi is equal to now cos of angle that we have calculated, which is equal to 67.38. Okay, so cos of 67.38 degree. So from here I have calculated the power factor, which is equal to 0.3846. Okay, so this is our power factor value. Okay, and next is that we need to calculate the inductance of the coil. Okay, so here inductance of the coil is now as we know that L is equal to or XL divided by omega, or we can say that the XL is equal to omega L. So from here we need to calculate the value of the inductance. So L is equal to now XL upon omega. So X of L is equal to, sorry, here now L is equal to, the value of the XL is 12 as I calculated here. You can see that this is the 12. Okay, divided by omega. Omega means 2 pi f. So 2 into frequency of the system into pi. So 50 is given to us in the question here. This is our question, 50 hertz. So from here the value of the inductance is now equal to, after solving this expression I will get the 0.038197 Henry. Okay, so inductance also we have calculated here. So we have calculated the resistance, we have calculated the inductance, and also we have calculated the power factor. Now remaining part is that the power drawn by the coil. Okay, so the remaining part will calculate like this. So next, power drawn by the coil when there in the question we have asked the two type of the supply. So we are calculating the power when the coil is connected to a AC supply. Okay, connected to AC. Okay, so we know that the value of the or the formula of the power is I square R. Okay, so we have the value of the resistance we have calculated here, which is 5 ohm. Okay, and the value of the current is already given in the question, which is 5 ampere in the case of the AC. So power is equal to 5 square into 5, okay, into 5. So power is equal to 125 watts. Okay, so this is how we have calculated the all the parameters which are asked in the question. So thank you very much. Kindly like and subscribe our channel.